We are now recording. Let's get on the current slide. And let me make these last few announcements. Okay. Preaching to the choir here, and just a very small choir at that. An ensemble. Okay. Have all of you done the student course evaluations? Yes? Not yet? Okay. Huh? Okay. Did y'all go and find the email that said something about Student Government Association voting and balloting and that kind of stuff?
Oh, yeah.
That's the one that has the link to the, yeah, that's the one that has the link. You can get to it otherwise, but that's the quickest way to get there. Go to that email, and they have a link. Click on the link, and you're right there. Okay? All the instructions are there. So please, folks, do the student course evaluations. I get feedback from you every day you're here, you know, minor things and stuff, but and some major things. But they also periodically ask for things like registration procedure, housekeeping, cafeteria, library, you know, some of the other things. That's their best source of input because they don't always get input. They don't see you every day, and they don't know what you're thinking. So please do those as well. But I really cherish and need to look at what students think about how I teach so I can improve the way I teach. And moreover, I'm a department chair. I look at the student course evaluation of everybody under me, and that's how I do part of their evaluation. So you need to do the student course evaluations. Okay. Yeah, Kiara is here.
Thank you.
Yeah, I've got it. Just finding you. Okay. Good deal. Thank you.
Okay.
Pardon me? Oh, okay. Okay. Now, yours were some of the piles of stuff that came in just in the last couple of days. I haven't got all those graded yet. I've got some of them marked, but I don't have the grades figured on them. So as soon as I do, like hopefully by the final exam on Tuesday, I'll have those back to you. I wish I had back today. I returned all the ones that had been turned in on time, but I just haven't had a chance to turn in to grade the rest of them. So I'll get those as soon as I can. Okay, I was just saying, have you done the student course evaluations? All right, good deal. Please do those, okay? If you want to wait and see what you scored and that kind of stuff, you can, but just don't put it off and then forget to do it, okay? Not worth it. Go on and get it done, okay? We need that input. Number two, let's talk about how the rest of the term is going. There's not much left. This is a day you've been dreading all term long, the last day of class, okay? Sorry about that, but get over it, okay? Now, where we go from here, whatever we cover, and hopefully we'll finish 2.5 and get into 2.6 and get most of that done today too. I got to quit talking and get doing that. But next week is a rather strange week for a couple of reasons. Final exam week for y'all, and that makes sense. But for mini-term classes, it's a little different because I have a Monday, Wednesday mini-term and a Tuesday, Thursday mini-term. Monday, Wednesday mini-term, their last class is Monday. Tuesday, Thursday mini-term, their last class is Tuesday. So next week I'll be administering exams and teaching classes. So that's why I want to give you my schedule. Today is normal, okay? As normal as it ever gets. I have this class, I have my next class, I have office hours between 10:45 and 1:15. Somewhere in there I try to eat lunch, but I eat it in my office, so you bought my lunch, so you're welcome to come see me anytime during that time period. And then at 1:15 I have class, and that class goes until 5:45, and once that's out, I'm heading home as soon as I can. Okay. So I usually leave after 6. All right, that's the rest of the day. Tomorrow, I'm on the Birmingham campus, as supposedly normal, 7:45 to 11:45, though I may be later tomorrow. They do have scheduled a meeting with a book company, and it's required attendance, so I've got to be there. I think it starts something like 10 or 10:30. I've got to find out for sure. But I should be there from 7:45 up until the time of that meeting, which I think is around 10 or 10:30. Okay? Now, I heard rumors of a second meeting, but I don't know what time that one is. Hopefully it's the same time and I don't have to go to the one. Okay, but that's decided. So I will be on Birmingham campus, but not always available because I will be in a meeting for part of the time. Now, if you are planning to come and see me at the Birmingham campus, especially to do a makeup or something like that, I need to know because, and I'm not talking to you, y'all have done everything, I think. I need to know because if I'll be over there without whatever you need. And let me just check. The two of you, have you done your first test? Yeah, okay, I remember. Okay, got it. Okay, so those will be graded soon, but I don't know when. All right, so I'm preaching to the choir then because all of you have done all your work. It's the people who are not here that may be behind in a test or something. So I will be there Friday, tomorrow. Now, let me give you what next week's schedule looks like, and it's rather strange. Monday morning, I'm here at 7:45, thereabouts, and I'm free until 2 o'clock. At 2 o'clock, I give my final to my Math 098 class. Okay? So from 7:45 in the morning until 2 o'clock, I'm free. You can come see me anytime. Turn stuff in if you still got things to turn in. Free in office hours. No classes for me up until 2 when I'm giving a final. Okay? Then, the final is supposed to be 2 to 3:50, but I have a 4 o'clock class on the Birmingham East Campus. Can't do that. So Dr. Bryant's going to come in and proctor the test. He's going to be here collecting his work finals from his class. So he'll just come in here and for the last 45 minutes or so, he will proctor the rest of that class. That's Monday. And then I'll go over there and teach from 4 to 6, and that's my last class for that. Tuesday, we have a test here. Now, the final exams are in almost 2-hour blocks, 8 to 9:50, not 9:15, 9:50. Now, your final on Tuesday will be, Brianna, right? Okay. Your final on Tuesday will be in 2 parts. The first part will be Chapter 2 test, which we're going to finish today, and the second part is going to be your comprehensive, which covers Chapters 1 and 2. Okay? They'll both be short, easily done, an hour each. In fact, most of you will be through less than an hour. Especially the final stuff you've already had, so it's just going to be old hat. Okay? Best things to study are your quizzes and tests that I'll return to you. Okay? That will be Tuesday, up until 9:50. Okay? 1:15, I've got my other mini-term class. That actually is a class. So from 10 o'clock approximately to 1:15, I'm free again on Tuesday. But then at 1:15, I'm in class. We're going to finish up everything we're going to do. We're going to have our last lab, last test, and I've got to give the final exam to them that day as well. Okay? The reason for that is I'm going to be out of town, in fact, out of state on Thursday. Okay, well, I'll get to that in a minute. Okay, Wednesday. Wednesday, I'm free all day long, 7:45 to 6 o'clock. I've already given the finals or their take-homes or whatever in all those classes, and they will have gotten things back to me. We'll be getting them back to me then. Now, Melvin's here. Just have to find you. Okay. Here's the deal, folks. If there's anything you owe me, okay, anything you're turning in late, I think all of you have turned in just about everything. Now, by the way, those who have come in late, at the end of class, I'll return your papers to you. I already returned them to people who are here. So at the end of class, stop by and pick up your papers. Okay. So, Wednesday is the last day you can turn something into me on this campus. Okay? I'll only be on this campus Monday through Wednesday of next week. Because Thursday we're leaving to go to Tallahassee for some visit, which seems totally ridiculous, but they required me to be there. Okay? Taylor is here. All right. For you who just came in, two things. First, have you done student course evaluations? Yes. Okay. If not, please do those. And number two, I've already returned papers to people. If you haven't gotten your papers, pick them up at the end of class. Okay. Now, I was just going over my schedule next week. So Wednesday, I'll be here, and here's Kaylee. Okay. Have you done student course evaluation? Good. Okay. I hope you know that the final exam is Tuesday, 8 o'clock. It goes 8 to 9:15. 9:50, not 9:15. And it'll be in two parts, the Chapter 2 test, which will be short, fairly easy, and the final exam, which will be short and probably even easier. Okay? So you should be able to finish each of those in 2 hours, in an hour each. So, all right. What was it? All right, so that gets me through Wednesday. Wednesday's my last day here on this campus next week. Thursday morning, I go to the Birmingham campus. I'm there from 7:45 or so until somewhere around 10 o'clock. Somewhere around 10 o'clock, we'll be leaving in a van to go to Tallahassee. Ridiculous trip at a ridiculous time, okay? So we're going, spend the night, visit with them on Friday, and then come back very late Friday night. So I will not be. So if you have anything to turn in to me Thursday, take it to the Birmingham campus, but you got to be there before 10 o'clock. After 10 o'clock, don't leave anything on the Birmingham campus. I won't be back there to pick it up. Anything after 10 o'clock on Thursday, slide them to my door down in my office, okay? And then I'll pick it up Monday morning when I come in. Monday morning, I'll be grading everything that's been deposited on my door and getting all the grades in and that kind of stuff. So that's, I don't remember if the grades are due noon on Monday or noon on Tuesday, but that's it. I can't receive anything after that because the grades will have already been in. All right, any questions on end of the term? Okay, then let's get to math. Any questions on math? All right. Their application here in section 2.5 is using a polynomial model. Polynomials are used to model all sorts of things, and this is sort of a dumb example, but it certainly works. You're designing candle making kits, okay? I've actually had a student or two who made candles, and I know one used to give them out at Christmas for Christmas presents, and they were very pretty and smelled great. So she was actually a candle maker. Each kit, now this is probably for a business, contains 25 cubic inches of candle wax. So it sounds like you're selling the kits and people are making their own candles, okay? 25 cubic inches of candle wax. And a mold for making a pyramid-shaped candle. Now, y'all know what a pyramid is? It's any figure that has a regular base and comes to a point at the top, okay? And that's where the wick would be, hopefully, if it's a smart candle. Okay. You want the height of the candle to be 2 inches less than the length of each side of the candle's square base. Now there, that gives you another piece of information. I said any regular base, this time it's a square base, okay? And you want the height to be 2 inches less than the length of the candle's square base. Now that's a very short, squatty candle. Seems like it would have been 2 inches more, but they said 2 inches less. What should the dimensions of your candle mold be? There's the question. Now the dimensions, what your answer will be, let me get my pen set up. It's usually a good idea to figure out what your question is. What are the dimensions? What two dimensions do they talk about here? Here's one, the height. Got to figure out what the height of the candle is. And the second is the length of the sides. Okay? Those are your dimensions. When you answer those two questions, you've completed the problem, right? Now, one of the first things you've got to do is figure out a relationship between these two quantities. They give it to you right here in this sentence. You want the height. What's the height? H of the candle to be. Now that's a form of the verb. That is the verb to be. Ramifications of that would be is, are, was, were, that kind of thing. So there is your equal sign. So the height of the candle, his sentence right here, we're going to translate from English to, in fact, let me do something. I wasn't looking ahead too well here. Let me get this scooted over a little bit. The height, that's one thing we're looking for, and the length, there's the other thing we're looking for. Okay? So this says the height of the candle, H, to be is, now, 2 inches less than the length. How do we write that as a mathematical phrase? 2 inches less than the length. L minus 2. The length is L, so that's exactly right, L minus 2. The height is to be 2 inches less than the length. Make sense? Okay. So there we have a mathematical sentence based on this English sentence that tells the relationship between those two variables. Okay? Now, another thing we've got to do is determine some of the parameters of this mold. And here they give you another thing, of the candle square base. So what's the base of that candle? It's a square, and that would be L squared. You're absolutely right. So the base of the candle, which is not a variable we're interested in, but the base of the candle is L squared. That's the area of the base of the candle, right? Now, one more question, and this is the one that's a little more esoteric. What is the, and what we're looking for here, what do cubic inches measure? 25 cubic inches. What's that a measure of? Second? I can't hear. Kilos? Is that what you said? Hey, my hearing's so bad. My legs are sore. Okay, say it again. What does cubic inches measure? You've got, each cake contains 25 cubic inches of candle wax. What's that a measure of? 10. An inch would be a measure of length. A square inch would be a measure of area. What would a cubic inch be a measure of? Volume, exactly. Okay? So what we need to know is the volume of a pyramid. Does anyone know what the volume of a pyramid is? Any clues? Guesses? Let me give you a hint. Okay? Volumes and cones, rather strangely, but they're very similar, are smaller than, okay, a pyramid is like a rectangular or square prism, okay? The volume of a prism is the area of the base times the height, okay? But see, a pyramid is going to go from that base up to a point. So it's going to be a lot less. And here is Fred. Okay. Need to take a time out and just go over a few things. Number one, have you done a student course evaluation? Good. Excellent. Okay, number two. The final exam for this class is next Tuesday, 8 o'clock. It goes 8 to 9:50, so we have almost 2 hours. It'll consist of 2 parts, the Chapter 2 test that we're finishing up now, and then the comprehensive part, which is 1 and 2. Both of them will be very short, easily doable in an hour each. Okay? In fact, some of them together will be about the length of your other hour test. Okay, so it'll be much shorter. Okay, so you should easily be able to do it. But if you need more time, always will be more time. And everything has to be turned in. Research, oh, I didn't say this earlier, but I thought everybody knew it. Research papers are due in today. I did say it earlier, but that's before most of you came in. Research papers are due in today. Anytime after today, you'll be losing points, but anytime today, you get this your score. Okay? Number 2. Oh, there's one. Excellent. Okay. Thanks. Okay. And any that came in late, any papers that you have, quizzes, tests, and things. Have any of you not completed either a quiz or a test? If you haven't completed it, I've returned them. You can't repeat it and complete it after now. So if you need to complete it, you need to go in a room next door and work on it. If it's a quiz, you can stay in here, but the test, you'll need to go next door and work on it. Okay? And for those who came in late, I'll give those back at the end of class, so I'll pass them out before at the beginning of class. Okay. And, yeah, I guess that's most of it. All right, so here we have, we're looking for a height and length of this pyramid-shaped candle mold. We know the height is 2 inches. The height is 2 inches less than the length. We know that H is equal to L minus 2. And we were talking about how to get the volume. And here's Chris. Got to go through these things again. Okay. Have you done the student course evaluation? Good. Not yet? Okay, please do that. Okay, number 2. It's not for a grade, but it's a requirement of the course. Okay? Okay. Number 2, the final exam will be, and research papers are due today. Yes, they're due today. If they come in after today, they will be, you'll lose points. You got it now? Okay.
Thank you.
Thank you. Okay. Okay. All right. Well, I was saying research papers are due today. Any quizzes or tests you haven't completed, you need to complete them now because I'll be returning everything to everybody at the end. People who were here before I already got theirs. People have come in since I passed those out. We'll need to get them before you leave today. So if you're behind a quiz or a test, you need to finish those right now, okay? Because after now, I can't accept them anymore, okay? And the final is next Tuesday, 2 parts, chapter 2 test, very short test, take less than an hour, and then the final exam, very short and simple. It'll take you less than an hour, okay? That'll be the 2 tests on Tuesday. Now, if Tuesday's not good for you, if you have 7 tests on Tuesday, I'm making this up, and there's some reason you just can't do it, you've got to get things made up. Either come in Monday and do it, or come in Wednesday and do it. Because Thursday, I leave to go to Tallahassee. It's not just me, a group of us are required to go to Tallahassee and see some building they've got there and some programs they got there, and it's an enormous waste of time, but the administrators like to spend money, and they require us to go. So I'll be leaving the Birmingham campus around 10 o'clock or so Thursday morning. So I won't even be on Bessemer campus Thursday. I'll be on Birmingham, but I'll be leaving around 10. So if you can get something to me before 10 o'clock on Thursday, get it to Birmingham campus, okay? Anything after that, bring to Bessemer campus, slide it under my door. Don't leave it anywhere on Birmingham campus. I won't be back there until I don't know when, okay? So be sure you get things done. Get it to me by Wednesday on this campus, Thursday morning on the Birmingham campus before 10, or anytime after that, slide it under my door. When I come in Monday morning, I'll wrap up the grading and get everything done. All right, let's get back to that. A prism is the area of the base times the height. A pyramid is the area of the base times the height, but only 1/3 of that because of the way a prism is, a pyramid is. So there is our formula. Now, if you didn't know that and never learned that, never was exposed to that, if you turn to the back inside cover of your textbook, you'll see they don't have it in there, okay? It'll be just like a right circular cone. It's 1/3 the area of the base times the height, okay? That's how it is for every cone. 1/3 the area of the base times the height. That's also true for pyramids, okay? Pyramids. 1/3 the area of the base times the height. You already told me the area of the base, L squared. So the volume of this pyramid is 1/3 the area of the base, which is L squared, times the height. There it is. 1/3 the area of the base times the height. But we know the height is L minus 2. So you can rewrite this as 1/3. Now my pen is doing strange things. L squared times L minus 2. Sorry about the pen, it's just going nuts. Okay, let's see if anything here will change it. Okay, now that would be 1/3 L cubed minus 2L squared. And that's equal to the volume. Well, your volume, well, you're told, it's 25 cubic centimeters of candle wax. So this is 25 cubic centimeters. There's your polynomial equation. Okay? Well, that is an equal sign because the pen is dragging like crazy. It's hard to read. Okay? How do you solve that polynomial equation? Second? Synthetic division? I would do a little something else first. Okay? For instance, that's not in standard form, is it? Okay? So let's get that first. And here's the other thing. Is there anything in there you don't particularly like the looks of? The what? Yes, I don't care for fractions that much. I know y'all love them, but I just don't really care for them that much. So I want to multiply both sides of that equation by 3. That's legal to do because it's an equation. As long as you do the same thing to both sides, it's all right. So that would make this quadratic to be what? Multiplying everything on both sides by 3. What would that give us? L cubed minus what? 3 times 2? 6L squared. And let's subtract that from both sides and make it a minus 75 equals 0. Now, why did I do that? That's your standard form. You don't want some number over there. If that was a linear equation, yeah, you want your variables on one side, the numbers on the other side, solid. But anything higher than a linear, you want everything on one side equal to 0. Now, any chance in the world you can factor that? Think not. Okay? We're going to need to do synthetic division, but we need to do it smartly. Okay? So basically what we have there is something you're going to need to use your rational zeros test for. How does that go? The rational zeros will be in a form P over Q, where P is what? Some possible factorization of your last term, 75. What are the possible factors for 75? Plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, plus or minus 25, and plus or minus 75. You got them. Now, aren't you glad we got rid of that 1/3? That would have made doing this really a miserable set. Okay? There's your P's. That's over your Q's. Okay? CJ's here. All right. I got to go over this again. Sorry, folks. Have you done sheet of course evaluation? No, please do them. Okay? Please do those. Okay, number two. Your final, okay, number two. Your research papers are due in today. If you haven't turned it in already, due in today. If I receive it today, you just get a score. If I receive it after today, you start losing points. Okay, you get a score, but it'll be less than what you would have if you get it today. Okay, number three maybe. I've returned all papers to people who were here at the beginning of class. So since you just came in at the end of class, come by, I'll give you your previous quizzes and tests. Have you finished all those? Turn those in.
Yeah.
Okay, good. Well, then I'll return those to you at the end. If you hadn't, you're going to need to go in another room and finish. Okay? Number four. Your final exam will be Tuesday, 8 o'clock. 8 o'clock. Okay? Finishing at 9:50, not 9:15, 9:50. And it'll consist of two parts. First part is your Chapter 2 test. The second part is your final exam, the comprehensive part. So they'll both be short, easily done in less than an hour each. So you should be able to get those done. If you need more time, you certainly can have it. Okay? Now, I went through my schedule for next week and tomorrow, by the way, too. Schedule for the day is normal. I have this class, my next class, from 10:45 until 1:15. I've got office hours. After 1:15, I'm in class with my second mini-term class. We'll probably go until 5:45. Okay, I'll leave campus sometime after 6. Monday, I'm free. I'll be Friday, tomorrow. I'll be on the Birmingham campus 7:45 to at least noon. We do have at least one meeting scheduled then. I think it starts about 10 or 10:30, so I'll be free early in the morning, but later in the morning I'm going to be tied up in a meeting. So if you need to see me early. There may be 2 meetings. I hope not, but if there are, I may be out more than that. Okay. Next week, Monday, free from 7:45 in the morning until 2 o'clock. At 2 o'clock, I'm giving an exam. I have to leave at 3:15 and get someone else to proctor that exam for me. Leave at 3:15 because I've got a class at 4 o'clock, mini-term class, over on the Birmingham East Campus. So I'll be over there wrapping up that class till after 6 o'clock. Then Tuesday I'll be back here. We have our test here, 8 o'clock in the morning until 9:50 or as long as it takes. Then I'll be free from then until 1:15 again. 1:15, I've got my second mini-term class, okay? And so they'll have class from 1:15. They're going to have their last lab, their last test, and their final exam because I'm going to be out of town on Thursday. That's when they would have had the final exam. So I'm trying to wrap up everything for them today. That's Tuesday. Wednesday, I'm free from 7:45 in the morning until 6 o'clock here on this campus. It's the last day I'll be on this campus this term, okay, until Monday of the next week. So anything you got to turn into me has to be into me on this campus by Wednesday. Thursday, I'll be on the Birmingham campus only from 7:45 until 10 o'clock. At 10 o'clock or so, we're leaving to go to Tallahassee. Wasted trip, but they require me to be there. So I will be there from leaving campus around 10ish or so and won't be back until very late, like 10 o'clock Friday night. Okay. And then, so anything you've got to turn into me that you don't get it to me before I leave Birmingham campus on West campus on Thursday morning, slide it under my door here, room 265, not this classroom door, my office door, 265. I'll pick it up Monday morning and get those things graded. And then grades go in either Monday at noon or Tuesday at noon. I don't remember which. Any questions? Now, if any of you are graduating, I don't think your grades have to be in earlier because the ceremony isn't until the following Saturday, is it? It's not the first Saturday. Right? Yeah, it's the second Saturday. So you have to be graduated. So I know I have to have the grades in. I think it's noon on Tuesday. I believe it is. We'll see. All right, so anyway, we set this up. We found our P's. Those are the possible values for that. Our Q's are the possible factors of the leading coefficient, which is leading coefficient 1. So that those are your possible zeros of your polynomial now. So let's start with the easy one, +1. Easy way to check +1, plug it in for L, okay? 1 minus 6 minus 75 is sure not 0, okay? No way. So then we do what Kendrick was suggesting, synthetic division. So let's start with, you know what? Let's be a little smarter about this. The L stands for the length of the side of the base. I want you to draw me a square base with a length of negative number. Can you do it? No. So let's forget about those minuses, okay? Forget completely about the minuses. Let's go to only the pluses. Just because of the physical nature of the problem. You cannot have a negative length. So since it's a physical handle, you can't have a negative length. So let's go. So 3 will be the next one. So let's do synthetic division on 3. Here's the 3. What goes on the other side? 1, -6, 0, and -75. Why? You have to account for every power. Here's a 3, a 2, we're missing the 1, so you have to have a 0, and then there's the constant. The other thing is, what's the maximum exponent? 3. You've got to have one more number here than that maximum. All right, got that done. Now we skip a line, draw a line, and do what? Bring down the 1, multiply, 3, add, -3, multiply, -9, add, -9. Not going to happen, is it? That's going to be a -27. No way you're going to get a 0 out of that. Scratch 3. That's not going to work. Okay? What's the next one you might choose to try? 5. Let's try 5 here. Okay? I left the 1 there. 5. Second. -1. -5. -5. That's not going to work either, is it? Scratch that one. Okay? Because that's going to do -25. That's not going to work. Okay? Whoa, I messed up my 1. Okay. Let's try, what's next? 15. Okay, what goes now? 15. -9. +9, you're right. What's that? 135. You know, there's something wrong with this problem. Whoops, made a glitch somewhere. The 5 was supposed to work. Oh, man. Wait a minute. Okay, let's scratch back. Okay. There's our problem, but I don't know where it came from. Let me get some of this scratch out of the way. Okay. Your 25 is equal to 1/3. Oh. You're right. You multiply the 3, and everything on this side was multiplied by 3. So that is, and you said it earlier, that was a 2. Sorry about that, folks, because it's the 1/3 wasn't multiplied by that, it's multiplied by the whole thing. So that'd be 1/3 L squared times L is 1/3 L cubed, and 1/3 times L squared times -2 would be 2/3. So when you multiply by 3, that leaves it a 2. Sorry about that. Okay. Whoa! All right. I was trying to go too fast. All right. That's a -2. Bring down the 1. Multiply. 3, 15, 15, 75. Ding, ding, ding. We got the solution. Your length is going to be 3 inches. L is equal to 3 inches. Now that's only the first half of your problem. It says what are the dimensions? You got the length dimensions. How in the world do we get the, and I wrote down 3. It's 5. I'm already doing the second part, but I can't get it to erase. Okay. Length is 5 inches. Okay. How do we get the H? Anybody? This one right here. H is equal to L minus 2. That's 3. That's what I was doing in my head. So the height is 3 inches. Okay? And then you can go from there and check it if you want to. And that's a fairly good-sized candle base, but a fairly short candle. Okay? To me, that wouldn't be very attractive, but I guess some people like them that way. I don't know. Okay? Let's see. 1/3 of the base times the height. The base times the height. 3 times 15 would 3 times 5 would be 15. That's the base. And the height. No. The base is 5 squared, 25. The height is 3, 15. 1/3 of that would be 25. Yes, we got it. Boy. Any questions on that? Really bites that up pretty badly. Okay, but there is your application. There is a checkpoint you can go back and do well, okay? Don't do it the way I just did. All right, that wraps up. Oh, wait. Let's see how they do it. Forgot that. All right, volume is 1/3 base times the height, where base is the area of the base, h is the height, area of the base is, they say x squared, I did L squared, it doesn't matter. And the height is x minus 2. That came from the sentence up here. H is equal to 2 inches less than the height. I mean the length. Height is 2 inches less than the length. So it's x minus 2 or L minus 2. And then you'd have, so far the volume is 1/3 x squared times x minus 2. 25 is equal to that. Multiply both sides by 25. That just makes a 75 over here. X squared minus 2. X cubed minus 2x squared over there. So there is our 75 equal x cubed minus 2x squared. Move that to the same side. 0 is equal to x cubed minus 2x squared, or L, whatever you use, minus 75. The possible rational solutions are plus or minus 1, 3, 5, 15, 25, and 75, just like we did. Use synthetic division to test. Note that in this case it makes sense to test only the positive L's, or x values. You can't have a negative length, okay, of a candle. So only do the positives. 1 didn't work, 3 didn't work, 5 worked. So you found the length to be, and here's Darius. Okay. Sorry about folks, got to go through this again. Have you done the student course evaluations? Okay, great. If you haven't, please do those. Number 2, research papers are due in today if you haven't turned them in already. If I get them today, you get just a score. If I get them later than today, you start losing points. Okay, I'll give you a score, but it'll be less than if you turn them in today. That's the second. Third, my schedule. I'm here on campus today I've got office hours 10:45 to 1:15. That's all I got office hours today. Friday, I'm on Birmingham campus, 7:45 in the morning until my first meeting, which I think is at 10 or 10:30. After that, I'll probably be tied up the rest of the morning. Okay? So if you're going to see me tomorrow, see me early. Monday, on campus here, 7:45 in the morning until 2 o'clock. At 2 o'clock, I got a final exam. At 4 o'clock, I got a class, a second mini-term class. So only good till 2, but from 7:45 till 2, I'm free. Tuesday, we have our test in here, 8 o'clock in the morning. It'll be in 2 parts. First part will be a Chapter 2 test, short. You can easily do in less than an hour. And the second part will be the comprehensive, short. You'll be easily do it in less than an hour. So you should be out in your hour and 50 minutes easily. If you need more time, I'll be here the rest of the day. Except at 1:15, I've got a class, second mini-term class, so we have our class, and then we'll be doing that. We'll probably be through with that class before 5:45, so if you do need to come back and see me before 6, you can probably get me before 6. I'll be here till 6. Wednesday, I'm free all day long, 7:45 in the morning till 6 o'clock in the evening. I'll be here on Bessemer campus. Last day to turn anything here in to me on the Bessemer campus. Thursday morning, I'm going to be on the Birmingham campus until 10, 7:45 until 10. Sometime around 10, we'll be leaving to go to Tallahassee. We're taking the van, pain in the neck, or some other part, and we'll be heading to Tallahassee. I'll be gone Thursday and Friday. Be back, so anything you need to turn in after 10 o'clock on Thursday morning, then you can turn it in to me on the Birmingham campus, West campus, but not after that. Anything after that, turn it in, slide it under my door, 265. Okay. Grades are going to be due either Monday at noon or Tuesday at noon. I think it's Tuesday at noon. All right. Did we see the rest of this? Yeah. The other 2 solutions satisfied or imaginary can be discarded. You conclude the base of the candle mold should be 5 inches by 5 inches, and the height should be 3 inches. Okay? And, all right. Good deal. Let's do the vocabulary at the top of page 162. The blank blank of blank states that if f is a polynomial of degree n greater than 0, then f has at least 1 0 in the complex number system. The blank blank of blank. What are we studying? It's algebra, okay? It's the fundamental theorem of algebra. Number 2, the blank 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 states that if f of x is a polynomial of degree n greater than 0, f of x has precisely n linear factors, and they would be f of x is some constant a sub n times x minus c1 times x minus c2 times x minus c3 all the way up to 1 minus x to cn, where c1, c2, c3 are complex numbers. That's the, not rational zeros, linear, okay, see if I can find that, linear factorization theorem. If you turn back 1 page to the summary, the first one, first summarized topic there, state the fundamental theorem of algebra, that was question number 1. Linear factorization theorem, that was question number 2. Okay. Number 3, the test that gives a list of possible rational zeros, hint, hint, of the polynomial function is the blank blank test. Rational zeros test. Good. If a plus bi, where b is not equal to 0, is a complex zero of a polynomial with real coefficients, then so is it blank blank, a minus bi. Complex conjugate. Very good. Number 5. Every polynomial of degree greater than 0 with real coefficients can be written as a product of blank and blank factors with real coefficients where the blank factors have no real zero. Okay. Either linear factors, which would have real zeros, or quadratic factors, and that's where it would not have real zeros. So the first blank is linear, the second 2 blanks are quadratic. Number 6, a quadratic factor that cannot be factored further as a product of linear factors containing real numbers is blank over the blank. Prime over the reals, exactly. Okay. Okay, number 7. The theorem that can be used to determine the possible number of positive and negative real zeros of the function is called blank blank of blank. Famous mathematician, responsible for the coordinate axes. Descartes, rule of sines. Excellent. Okay, not much help. Okay. Number 8. A real number C is a blank bound for the real numbers of F when no real zeros are less than C. If no real zeros are less than C, that must be a lower bound and is a blank bound when no real zeros are greater than C. Upper bound. Okay. Homework exercises, either 9 or 13. No, any of the odds 9 through 13. 9 is at calcview.com. All of them are at calccheck.com. Do either 15 or 17. They're both at calccheck. Any of the odds 9 through 27, they're all at calcchat. 25 is at calcview. 29 or 31, they're both at calcchat. 29 is at calcview. Either 33 or 35, calcchat. 37 or 39, calcchat. 41 through 45, calcchat. Well, you don't have to do any of those. They have imaginary parts. Same thing with 47 and 49. They have imaginary. So, 51 or 53, they're both at calcchat. 55 through 59, they're all at calcchat. 55 is at calcview. Any of the odds 61 to 71, they're all at calcchat. 69 is at calcview. Any of the odds 73 to 77, they're all at calcchat. 79 to 85, they're all at calcchat. 83 is at calcview. 87 or 89, both at calcchat. 91, 93, both at calcchat. 95 or 97, both at calcchat. 99 or 101, both at calcchat. 103 through 105, both at calcchat. And there's some think about it, some things. 117 would be another decent one to look at. Any of the others you see there. Let's see what we can do on rational functions. Not much, but let's see what we can do. Wait. All right, 2.6. Sorry, I wish we had more time for this one. My being out for a day with sickness and then the days we lost with weather early in the term really hurt. And PowerPoint slow. It's a big surprise. Well, all right, finally. Okay. Polynomials and rational functions. Rational functions. This is one section on this. We'll find domains of rational functions, vertical horizontal asymptotes of graphs of rational functions, sketch graphs. I doubt if we'll get that far of rational functions. Sketch graphs of rational functions that have slant asymptotes. We won't do that at all, even if we had time. And rational functions model real-life problems. Doubt if we'll have time for that. So let's look at the introduction. What is a rational function? We've been talking in this whole chapter so far about polynomial functions. Well, a rational function is sort of related in what is the first 5 letters of rational? Ratio, which is a division of 2 entities. So a rational function is a division of 2 entities, but what is it dividing? Quotient division of 2 polynomial functions. So the numerator has to be a polynomial, the denominator has to be a polynomial. This is how we usually write it. F of x, some books say R of x for rational, is the numerator of x divided by the denominator of x. Both of these being polynomial functions. N of x, d of x, polynomial. D of x is not the zeroth polynomial because you still can't divide by 0. Okay? In general, the domain of a rational function of x includes all real numbers, we assume, except those values that make that denominator 0. You can't have a 0 in a denominator. Okay? So much of the discussion of rational functions will focus on their graphical behavior near the x values excluded from the domain. And that's an important feature. Okay? So let's just look at one. This is a very simple function. F of x is equal to 1 over x. Number one, what do you think the domain of that function is? We always assume all real numbers unless something makes that impossible. What would make that impossible? X equals 0. So all real numbers except x equals 0. X equals 0 is the y-axis. So it's never going to cross the y-axis. It's not going to have the y-intercept. Okay? Is it going to have an x-intercept? X-intercept is where y is equal to 0. Here's your y. Is 1 over x ever 0? The only way a fractional form can be 0 if the numerator is 0. 1's not 0. So it has no x-intercept, no y-intercept. It can't hit the y-axis at all. Won't touch the x-axis at all. Whoa, what's this thing going to look like? Okay? So that's where it says find the domain of this. We've already decided all real numbers except x equals 0. Discuss the behavior near that x equals 0. Well, when x gets close to 0 from the positive side, give me a number close to 0. 1. 1 over 1 is? Okay, so y is 1 there. Okay? Give me something closer to 0 than 1. Closer to 0 than 1. Okay? 1/2. And what's 1 over 1/2? What's that value? 1 divided by 1/2 is 1 times. Divided by a half, which is 1 times 2 over 1, so that would be 2. So when x equals 1/2, you're at 2. How about 1/3? 3. 1/4? Okay, what's happening? The closer you get to 0, the greater and greater the number is. Guess where it's heading? Positive infinity. What if we put in a decimal number, like 0.000000001? Then you would have 1 over that many zeros, 1 over a million, or something like that. Closer and closer to 0, never getting there. So it's going to infinity. How about if you go try to approach 0 from the left-hand side? What's a number close to 0 that's on the left-hand side? Negative 1/2, that would give you. Negative 2, negative 1/3 would give you. Negative 3, negative 4, negative 5, negative 6. Guess what? Going to negative infinity from the left-hand side. Okay? Now, what happens when x gets very, very large, your end behavior? Where is this going? 1 over a very large number is going to be close to what? 0. Both positive and negative. So here's what your function looks like. Okay? Because the denominator is 0 and x equals 0, the domain of that is all real numbers except x equals 0. We did that. We figured that out right off the top. And then we looked at what's happening as you get close to that 0. From the left-hand side, you're going to negative infinity. From the right-hand side, you're going to positive infinity. Same thing we were doing. Okay? Note that as x approaches 0 from the left, f decreases without bound. In contrast, when it approaches 0 from the right, it increases without bound. Here's what it looks like. The graph is shown here. As it approaches 0 from the left, going to negative infinity. Approaches 0 from the right, going to positive infinity. As x is very large negatively, it's getting closer and closer to 0 from the minus side. As x approaches very large numbers from the positive side, it's approaching 0 from the positive side. So here's what we say. The end behavior here is x is going to 0. We call that a horizontal asymptote, where x can't equal 0. That's a vertical asymptote. So y is equal to 0 is a horizontal asymptote. X equals 0 is a vertical asymptote. There we threw in those two words that we saw in the first thing. And what we usually talk about near a zero, as x approaches 0 from the left, y or f of x is going to negative infinity. As x approaches 0 from the right, it's going to positive infinity. So that looks a lot like we did for our M behavior, but we've already hit our horizontal and vertical asymptotes. Okay? Fortunately, sadly, we're out of time. Okay? So your chapter 2 test just got a little bit easier. Okay? What I'll do, any questions that cover 2.6, those will be optional. Okay? So you'll only be covered through 2.5, and same thing with the final. I can't remember if any of those will be in 2.6, but if they are, they'll be optional. Okay? Because they're already made them. Oh yeah, and anyone who came in late and didn't get your stuff, let me pass them out to you. But let me